This is the first session, and you're gonna all have access to the drive, which you should either through the WhatsApp group or I'm gonna link it down in the description. But this drive contains every single session with summaries and exercises and basically everything that you might need for your whole COE journey. Not COE as a course, as this course. So we've got session 1, session 2, session 4, and once you open them up, you have the actual the PDF that contains all the explanations as well as the exercises unsolved, and then the solutions of the exercises. So this way here is pretty easy access. You just access the drive. This is the explanation slide. So we're gonna go over this one today, and this one is the solution. So it looks like this. The solution is gonna be, so we've got MCQ, and basically for the first couple of sessions we're only gonna have MCQ, and then later maybe some output, and then later some coding problems. Perfect. I think that's it. So I think we can start with session 1. One more thing I want to add is that every time that we're done a session, I highly suggest you do the exercises. So at the end, we're gonna go scroll down. We have these exercises, and I highly suggest you go through them all. They just take they take around 15 minutes, and then you check the solutions. These exercises, they are made by, and the summary, they are made by a woman. Her name is Raya Badran. She used to be a student here. She was a tutor, not my tutor. She tutored the people before me, kind of. She's great, and really we have to all be grateful. I wouldn't have gotten done well on the course if it wasn't for her amazing science, or done as well. Anyways, so let's get into it. First of all, we've got chapter 1. So I don't know how it's divided, but chapter 1 is just speaks about Java as a whole. What is it? So the whole thing that Java does is it turns something that we speak, commands, into a machine language. So the machine language in the case that we know is going to be bits. So it's zeros and ones. Let's see if there's no mention of it here, but zeros and ones. I'm sure you all know that the code runs on ons and offs. 0 1 0 1 0 1. So we do not, unfortunately, speak 0 1s. So just to give you an example, if we had to type everything in bits, type them down in 0 1s, letter A is representative by 9 zeros and 1s, I believe. You could search up the ASCII, ASCII unit for the letter A. It's 9 0 and 1. So you can imagine how complicated it would be. So Java here really helps us out, and Java is a high-level coding language. So it's as if we're communicating with it in English. So what's the whole the way it's divided? So if we go down here, you could see that algorithm, and in this case, it would be some type of solution that we came up to. So we will have a problem. We'd solve it by writing down a code, so which is our Java source code. That's what we call it. It will go through the Java compiler. And now, what is the compiler? The compiler basically, it translates everything into bytecode. All right, bytecode is a code that we do not read. Me as a human being, I cannot, and I mean, you've probably seen the bytecode. It's unreadable. So, but the compiler just turns this into the bytecode, and the way the compiler does it is it looks at it all and it immediately translates it all. So we're going to see there's the difference between a compiler and an interpreter. Compiler, immediately, it will take the whole thing and translate it immediately, the whole thing. So this is where you get your dot class. So if you ever wondered when you're in your command prompt and you have your good morning Java file, You see, it's saved here as a Java file. Now, when you went and you put Java C, you turned it into a class file. You used the compiler. You've compiled it into a class file. Now, if we open up the class file, this notepad, does this make any sense? No, 0 sense. I cannot read any of this, right? If I look at the source code, oh, okay. I'm just trying to say hello world. Perfect. So this makes sense to me. But the class doesn't make sense. Bytecode, it's Java understands it. So you can see the Java compiler gets the Java, turns it into a Java bytecode. Now, in Java bytecode is then sent to the Java virtual machine. So the Java virtual machine is basically like, if you want to imagine it essentially for our purposes, it's a black box that just works on turning this bytecode into machine code. So turning this the bytecode into machine code. And why do we say that Java has both a compiler and an interpreter? Now, we understood the compiler deal. I've turned it into bytecode, and it turned into a .class file. So we've compiled it into a .class file, bytecode. Where does the interpreter? Where is the interpreter in Java? Now, the interpreter in Java is in the Java virtual machine. What does an interpreter do? As you could see written here, it turns each line and it will translate each line by line. So it's going to go line 1, it will translate it. Line 2, it's going to translate it. Line 3, it's going to translate. The compiler reads the whole thing and translates it immediately. This one, it's going to read it one by one and then translate it. So the interpreter. So you could see compiler will turn it into bytecode, and the interpreter will turn it into machine language, which is zeros and ones. It's a bit more complicated than that. You also have a compiler within the JVM, but it's a simplified version, and this is how you want to know it. So just to give a quick summary, recap, I start with my Java source code, right, which is what we have here. This is my Java source code, public static void main. Right, I compile it through the compiler. Immediately will translate everything and turn it into a .class file. So this is bytecode now. Right, it turned it into bytecode. This bytecode is, when I run it, is sent to the JVM, and the JVM has an interpreter as well as a compiler inside it, and through the interpreter and compiler, they work together in order to give me machine code, which the operating system, your OS, can understand. Great. So we're done with the basics of how Java works. And again, you can ask me questions. Either you send them on the WhatsApp group, you can comment them down in the YouTube comments, or you could ask me the questions when we're live. Perfect. Let's continue. Java program main remarks. Okay, so here we're just gonna go a bit about Java program and its syntax. So one thing that I want you guys to understand is Java is a dumb program. Java is super stupid. What does that mean? That means that unlike a human being who can interpret or think about what a person said and make their own decision, Java, there's no interpretation, there's no thinking. It just does. So if I made a spelling mistake, Java is not going to say, oh, this word looks familiar. He probably did a spelling mistake. I'm just going to run it. Nope. I don't understand what this word is, right? It completely, I have no understanding whatsoever of this word. And this is where the compiler is going to give me an error, and I'm going to get the compilation error. So we're going to talk about this later on. Why compilation? Because it did not understand what I wanted it to do. So this is what's important to understand. Java is a dumb program in the sense that it does not understand anything. It just does what it's told to do, and it must be told exactly with the steps what to do. Otherwise, it's just going to do exactly what you said. And if you had the spelling mistake, it will not understand. Gone. Or if you had some logical mistake, it's not gonna try to fix it. That's it, it's gone. Anyways, here we have every line of code will end with a semicolon. So here's just some basics that I'm sure you all know, and I think you can go through them, but just some important things is whenever you want to comment. So why do you want to comment? Is for your sake, tidiness of the code. So let's say you're coding up something pretty big and you kind of want to know later on what this does. You would put a slash slash and you'd write next to it, this does this, for example. If you have a code that is multiple lines, you could do a slash, then star, and then a star, and then a slash, and write whatever in several lines. So you could press return key as many times as you want, and then java.comment. You're not responsible for it, and but essentially it creates a separate document, and it's used for documentation when working with big projects. Anyways, to continue, another thing that you need to know is there are identifiers and reserved words. So if you are familiar with the concept of variables, later on, you're going to have to assign certain variables. Well, Java, there are certain words that Java recognizes, and they're called reserved words. So these are basically like string, out, and main. So I cannot name a variable main, or I cannot just use string like that, right? I could write it within a string, but the whole idea is that these reserved words, Java recognizes them and they have specific meanings to Java. It's not like a something that I could name some variable and then use it later on. No, this means this for Java already. You cannot assign a meaning to it. It already has a meaning, and this meaning was given by other programmers who worked on Java. So you have basically class, static, and these are all words that later on you're gonna learn what they are, what they mean to Java. So another thing is that Java is case sensitive. So you might have noticed if, for example, I named my class Good Morning here. If this class right here, it's the name of the file is capital G, but if I put this as a lowercase, right, I'm gonna have an error. Or if I put the M here as capital, I'm also gonna have a problem. So perfect. I'm just gonna change it just because it is case sensitive. Again, this goes back to the idea that Java is dumb. If it sees G and capital G, it's not gonna say, "Oh, these are different. These are the same things." He probably meant that this is the same thing. No, these are different things. Capital G, small g, super different. Anyways, then we have the types of error. So we went over a bit syntax error. So that syntax error, as we said, it cannot be identified by the compiler. So the compiler looks at it and is like, "Whoa, Java does not understand. What is this? It doesn't make any sense to it." So this is a syntax error. Then we have runtime error, and runtime error is essentially an error that happens because Java, it understood what you asked it to do. It's gonna do it, but it just can't do it. So that's something like dividing by zero. If you take your calculator and you divide by zero, you get a math error. It's the same thing. It's a runtime error. The program is like, "Okay, yeah, I understood. You want to divide by zero? I'm gonna try it. Oh crap, I cannot do it." So yeah, that's a runtime error. Then we go to logical errors. Logical errors is basically an error when you try to solve a problem, but your output is not what you desired. So I don't know. Let's take any simple problem. You want to do addition, right? But your program subtracted the two numbers, right? This is a logical error. There was no syntax error. It was able to compile. Java was able to compile your code. There was no runtime error because it was able to run your code. It ran it, no problem. It gave me an output. Logical error. It did not do addition. It did subtraction. So this is now here where we get to the coding part, and I'm just gonna go over some basics, and you could later read it on. I'm sorry that maybe this is a bit too basic, but I'm just gonna go a bit over a few things here very quickly. I think, let me just check. This has been going for 15 minutes now. Oh, I feel like we're good. Anyways, let's just okay. So now that we've explained everything, let's start with the actual code. So every code starts with the public class, whatever. So if we see, and I'm sure now you know this. Oops. public class good morning. So here's the class name, right? So what am I saying basically to Java? I'm saying, okay, I have a public. Now, public is what? Public, you might not make, it doesn't make any sense right now, but think of the meaning public. Public means everyone can see it, right? So the whole idea is that I'm telling Java, hey, this is a file or a class that I want everybody to see. I want all files to be able to access that. So even your command prompt, it can access it because it's public. So later on, you're going to learn a bit more, but just to give you an idea. And then class, why? Because we are creating a class, right? So a public class, and we name this class, right? So here, let's go up. Public class, perfect. Then we're gonna go down, and we're gonna have our main. If let's just, it's basically our main method. What does that mean? The main method, later on, you're going to learn that there are various types of methods, right? And there are many methods. Actually, there are two types of methods other than the main method, but you could do many types of methods that do different things. But this method in particular, okay, is the main method. What does that mean? It is the method that runs. So main method is the instructions that Java follows, right? If you later on, you will have all these methods, okay? These are going to be as if separate papers that if you mention it to Java, Java will go read it, okay? So you want to imagine that the main method is basically the instructions. If you don't understand it, you can a bit forget about what I said earlier, but just main method is the instructions. So again, we have the public because I want Java to be able to see this. And then we have here static void. We're going to get to know a bit more what the static and void mean, but void essentially means do not return anything. Now you might think, oh, whoa, do not return anything. So the return type is void. Return type is void, so I'm not returning anything. What do you mean return type anything? If I'm printing out something, it is returning a string. So it is printing out something. But what actually is happening is you told it to print something. Later on, you're going to see there are methods that the return type will be a string, and you will not tell it to print. You will just tell it to return something, and it's going to return that. Even though you didn't tell it to print, it's going to output a string, but you didn't tell it to print because its return type was a string. So if you're just a bit confused by this, it's okay. Don't worry about it. But void, so that means it's just going to do what you instructed to do. It's not going to do anything extra. So again, save your text file, the same as class file. Then we have some basics, system.out.print, print ln. ln goes back to the next line. So again, system here, I'm accessing the system out because I'm outputting. I want to see an output, which I'm going to be printing. Perfect. Concatenation. What is concatenation? Concatenation is basically addition. It's a fancy name for addition, but addition between strings. If I now did this, my name is Raya plus Badran, okay? I'm going to get, my name is Raya Badran, okay? In this case, Raya Badran made these PDFs. So I would say my name is Kirill plus Irani. Or I could just have wrote, my name is Kirill Irani. Perfect. Now, you might think, okay, concatenation, other than for MCQ and stuff, why would I use it? So you're gonna use it for one reason, and that's gonna be your paper you're gonna run out of space on your paper, right? So you're gonna have to, if you're going because you're doing the test on paper, as you do it on paper, you need to go. Sometimes the string is so large that you need to go down the next line. Can I go down the next line without putting a plus? No. Why? Again, because Java is going to be like, I'm reading this. Okay, my name is Raya. Hey, wait, there's something wrong here, but let me go down to the next line and check. If I just immediately see a comma, a quotation, Java's going to go, whoa. What's happening? Two quotation marks next to each other. This makes zero sense. Compat time error. My name is, okay, let me check down. Oh, there's a plus sign. Okay, perfect. I'm just going to add whatever's next. Okay, string plus string. Okay, I'm going to just add them up. No problem. So this is how Java actually goes. So you could actually see here that as well, in addition, the Java, it has a bit here. So this is basically an idea of how it treats integers. So for example, when I have 1 plus 2, it's gonna say, oh, 1 plus 2, okay, perfect, that's 3, easy. Plus m, 3 and m, they're not integers, so it's gonna be 3m. Okay, plus 3. Okay, so that's because now I added a string. Okay, it's gonna treat everything to the right as a string. So this number here is not gonna say it's an integer. For it now, it's gonna be a string. So I'm gonna have 3m3 plus 4. So 3m34. Perfect. Uh, then we have the idea of variables. Again, variables, we did mention it quickly, is basically it's somewhere you give it a name, but it's essentially a data storage. Okay, so for example, when I specified here that integer, so I said integer total is equal to 1, I named the variable total, but I said it's equal to 1. So total, this variable, is now storing the value 1 as an integer. So variables and assignment, it's split into two: declaration and initialization. Declaration is basically you're just declaring it. I'm just saying integer total. I'm declaring it out loud. I made a variable. It's an integer. Its name is total. Now initialization is when I give it a value. So when I said total equal 1, it was initialization. Here is an initialization plus a declaration. I declared in total, then I immediately assigned it 1. So I initialized it and declared it. So these are basically just things that you have to like think about. Not necessarily just know in the back of your head, just terminology. Then we have a bit here, some things about strings, some fancy things. That backslash. The backslash is a special symbol. When I do a backslash with a T, it's gonna give me a tab, which is basically like 8 spaces or something. When I do a backslash and an N, it's gonna take me to a new line, backslash and double quote, and all this. So I'm sure you know a lot about this, and there are some great exercises down below that are going to test you about the backslashes and how will they look like on strings, and how will it affect my output. So if you have any questions, you can always ask me. Then we have constants. So essentially constants, we put a final modifier. So again, if I have int total, right, I'm going to say final int total. That means I cannot change it. So I'm just going to give you a very quick example here. So this is an IDE, by the way. You might not be familiar with an IDE yet. You will use it sometime in the future. An IDE is basically, instead of me having to open the command prompt, it has everything for me ready to use within an environment which has the access to JVM. I can run everything. It compiles it automatically. I don't need to create a class file or a Java file. Everything is just stored here. It's a very nice and quick way of using. So I can, in this case, for example, if I put in total equals 1, so I've declared and initialized a variable. It's called total. So if I just run it, see, I'm not going to have anything because I just declared and initialized it. So I'm just going to see here, basically there was nothing printed. So if I just go down and then I say system.out.println, let's just print total. Of course, we shouldn't forget about the semicolons. You see how it puts it out to red for me? It just helps me out. 1. Okay, perfect. Now let me say total equals 2. Now, because I did not change anything, it's not a constant, I can do this. I can change the variable anytime I want it. So it should give me 2. Perfect. I can change the value of the variable anytime I want. And so you see here is giving me a highlight because it's saying that, yo, this is useless, this equal to 1. Because you just said equal to 2 right after and you didn't even use it. Anyways, let's say I put final before. Final. Okay, immediately lighting up total equal to. Why? Because I'm trying to change the value. I cannot change the value. That's why it's telling me here, if I press remove final modifier, if I want to change it, I need to remove the final. Or I just delete this and everything is perfect and I cannot change the final. Now again, why would I use the final later on? If you're doing a big project, you might want to keep some values strictly, they never change, especially if many people are working on the same project. You're just saying this value is a constant. Okay, perfect. Let's continue. Um, so again, you get the compile time error because for Java it's gonna say final, okay, and then you try to change it. Yo, this makes no sense. I cannot run this, compile time error. Then we go over the primitive data types. What does that mean? Primitive data types, it's just basically the most basic data types there is. And you might think string is a basic data type, but no, string is not a basic data type. The reason we know that it's not a basic data type is, or primitive data type, is due to the capitalization. If you notice, int has a small I, but when we wanted to, let's say if I wanted to save something as a string, here, I'm gonna save the number 1 as a string. If I wrote a lowercase s, it gives me an error. If I put a capital case S, okay, sorry, we have to put quotations. So let me just do that. S, lowercase s, problem. Uppercase S, no problem. Perfect. Okay, so that's why we know that this is because it's uppercase. String is actually a class. So people actually created string, and you're using this class. And you're later on, you probably have seen that I need to import some classes, but string is you don't need to import it just because it's people use it a lot. So they just made it that hey, you shouldn't import it. We use it always. Anyways. So you've got all these types of different forms of integers. You've got byte, short, int. Int is the most commonly used. Well, the difference is that the amount of bits that is stored. So I'm not really sure which one. Long, I believe, has 64 bits. Int is 32 bits. Short is... So each bit corresponds to a number. So usually int is enough, 32 bits. Short is, I believe, byte is the smallest with 8. So you just do 2 to the power of 8. 2 to the power of 8 will give me the largest number that I can get, which is, I think, 120, I believe. I might be wrong. Don't quote me on it, but just know that these correspond to different bits, and so it limits the overall size of my number. Then we have floating numbers, which is basically decimal points. And again, difference between float and double is the bit size. Characters is single character. So what's the difference between a string and a character? We could say a string is a collection of characters. But so I could save this not as a string because it's a single entity. I could save it as a character by putting a single quote. And this one here, just car. Perfect. We just saved it as a character. And later on, we're going to see why characters are used. Boolean is basically true or false. It's just it either holds two types of information: true and false, 1 and 0. Then we have the arithmetic equations, expressions, plus, minus, times, divide. Modulo will give me the remainder of a division, all types of things. Then we have the incrementation, something very nice, that if, let's say, I wanted to increment something, you will use this a lot in loops and stuff like that. Later on, you're going to learn. But the whole idea is you have the postfix and the prefix, and essentially the postfix, it's a bit of a confusing thing, but instead of writing count equals count plus 1, so basically I'm saying that whatever value of count is here, let's say it's 0, I'm changing the value of count. I'm saying whatever the initial value, just add to it 1, that's the new value. So, and the same thing with minus. You could do it by using the plus plus. Now, what's the difference between count plus plus and plus plus count? They're the same, except when you are doing something. So, I'll show you now an example. But again, we also have plus equal. So plus equal is the same thing as all of this, or minus equal is all the same. And plus equal, you can also use it for string concatenation. So basically, I could put a string plus equal something else. So it's gonna immediately add up both. Here we have data conversion. I'm going to go back to the post prefix last thing. Data conversion, again, we mentioned that byte, short, int, long all has different storage with different values and minimum and maximum values. So essentially, you can change it. So let's say I saved something as a byte initially. I can convert it into an integer. It's called widening. Why? Because it's it's low storage. I went to high storage. Like I had a box that fits into a room. If I take it into a bigger room, of course it's gonna fit, so I have no problem. Narrowing is a problem though. When store something as a long and I want to take it back into an int, it's a problem. Why? I have a box that is big, okay, and I take it into a room that is smaller than the box. I cannot fit that box. That's a problem. So narrowing should be avoided as written here. Widening is no problem. So as you can see here, by for example, if I go from a float to a double, no problem. From a double to a float, problem. How do I convert? We've got different conversion techniques, right? Again, if I try to narrow, it's gonna give me a compile time. Think back to the box. Now, how can I widen? Now you can widen by just quite literally here it's mentioned either promotion or casting. So you have two types, promotion or casting. What does promotion mean? Promotion basically means that if I am using an integer and a byte, immediately the byte will be promoted to an integer, right? In order for that operation to happen, because any operation, it needs to be between two similar. So if you think of it, the example that I gave you where I had a string, the 3m3, let's go back up, 3m34, that was a sort of promotion, if you would like to call it that way, because I had 1 plus 2, then I had a string. Now we know as this string, right? Because I had this string, it will promote the rest into strings. So it's going to treat the rest on the right as strings. So that's basically it. And then we have casting. And casting basically means that I am telling Java that this is this type, and this is by just before it, you put parentheses and you put what you want it to be. This is casting. So I'll give you a very quick example. I'm gonna make an integer. It's gonna be total as 1. Now, if I'm gonna say string T, capital T, so this is again case sensitive, I'm gonna say it is string total. Let's see if this gives me a, again, this is gonna give me here. Why? Because because I can't convert this except by promotion. So the only way I would be able to convert this is by doing something like this. Where is it? Where is it? Here. Plus. So again, here I did empty plus total will give me now, because I've promoted it. I cannot use the conversion here just because they're not the same type. They're not a number. So now if I wanted to convert it into a long L total equal long total. Now this works. I could also just remove the long, and this works as well, just because it's gonna immediately promote it. Now, what if I had a byte here, and I tried to cast it into byte? See, this works. Why? Because I've casted it. Promotion only works when you're widening. Here we narrowed, but I know 1 belongs, so I'm not going to get any errors, right? I know 1 belongs to the byte. Now, if I try to increase the number, something like this, we have a big number. We've changed it into a byte, right? But it's going to give me now an issue, I believe, when I'm running it. Although it doesn't immediately recognize it here. Okay, we have somehow did not give me any problem with this storage to a byte. That's odd. Let's try to print L total. I believe it's gonna give me the maximum value. It's 122. I think it's just giving me 128. Let's check. Oh, minus 66. Yeah, there you go. So essentially, when I turned it into a byte, I've lost information. I've lost data. This box, I cut a bit of this box in order to fit it into this room. And when I cut a bit of this box and to fit it into this room, I lost data. And so my 122222, whatever that number, became negative 66, which is not the same at all. I did not get a compile time error. I got because I forced it by casting. I forced it to turn it into a byte, but again, I just cut the box essentially. Promotion is something natural, okay, but casting is something unnatural, and I'm forcing it to do it, if you will, as if I'm doing it at gunpoint, and it's not working. So finally, we have object declaration, and this is where we come to the idea that string is actually a class, and every class, okay, has an can be turned into an object. You can create an object from this class. It's basically something usable from this class. So the string class is a class, and we've created an object. The way you create an object is through this object declaration, which later on there's a specific session which goes deep into how to declare objects. But essentially, it's string name equals new string, hello world. Well, that means this is how you declare an object usually, all right? But because string is such a commonly used thing, now you could immediately use it as if it's a primitive data type, as if it was a normal variable from a primitive data type. Now, I don't want you guys to think about it much because we're going to discuss this later at length, object declaration. But all you need to know is that string is actually a class, and that's why, but because string is used so often, we think of it as a primitive variable, and we use it as a variable. And I'm sure you've went over the scanner class and how you're making a new object from it. So scanner scan equals new scanner. So you named the scanner scan, and you made a new scanner, so new object. Okay, this object, it's this class, but you made a new object from it, and then here it's a parameter that it takes. We're gonna discuss it later. So I think this is pretty much it. Hopefully, if you had anything, this summarizes chapter 1 and 2, and if you have any questions, you can ask me. You can read through this. I think this is a bit long, so I'm going to try to speed the next ones up a bit, hopefully, so not all of them end up this long. I don't know if anybody's going to watch this, but if you are, let me know if you actually watch this whole thing. Let me know if it's good, if there's anything that I can improve, because this is the first time I'm doing something like this. And then here there are practice exercises. So for example, if I'm going to do the first one, the output of the following statement is system.out.println. Okay, I'm printing something. 11 plus 4. Okay, this is an integer, this is an integer, that's 15. Plus 32. Oh, 32 is a string, so I'm going to have a promotion of sorts, so it's 15, 32. 6. Okay, since this is a string, everything to the right will become a string, and I have concatenation, so I'm going to have 15, 32, 6. 1532 6. We can check the answer here. 1532 6. Perfect. And so here's a bunch of problems. I just remembered as well. Let us go over very quickly the postfix prefix. What's the difference? Essentially, what it does is count plus will give me the value of count, the current value of count, and then it will add for me 1 to count. And in the prefix, it's gonna first add 1 to count and then give me the value of count. So when I'm using it in an expression, count plus plus will be as if I just used count, right, in an expression. But later on, if I used count again, it's gonna be the initial value of count plus 1 because I did plus plus before. And here, because I do plus plus count, it will immediately treat the count plus 1. So just to illustrate this, here I have int count equals 0, system.out.println count plus plus, system.out.println count. if I'm going to run this, okay, what I'm going to observe is first, I'm going to print the value 0 because it's the initial value of count. So here we have a 0. But then, because I added plus plus, I've changed the variable, the value stored by the variable. I've added 1 to it, so it's 1. So when I print it again, it became 1. So now, if I do the opposite, what I'm going to see is actually it's going to be 1 in both cases. Here, plus plus. Now I press run, it's going to be 1 in both cases. Why? Because again, now it's going to change the value and then use it. In the other case, it uses the value, then changes it. Here, I'm changing the value and using it, and that's why I have 1, 1. So that's pretty much it. Again, as I've said before, if you guys have any questions, you can ask me. This is a pretty long session, but hopefully it was good, and some people find this useful. All right. Ow. Bye. Do the exercise, by the way.